Hello, everybody.
Hello, Torben.
Yeah, thank you very much for the opportunity to present our products. I will do the next two presentations before we do lunch at 12 o'clock. Maybe
Yes, thank you.
a couple of words to myself. My name is Torben Bauch. I'm the head of product management at GEA Brewery Systems. I'm with GEA now for 4 years. My background is actually, I'm not a brewer. I'm a bioprocess engineer. Yeah, and before of that, I worked for 10 years in the yeast and yeast extract industry. So mainly, yeah, worked with yeast. So that's why I'm also responsible for the yeast propagation plant that you will see now. We have, what we've done here, we have designed the GEA Craft Yeast Propagator. It's a yeast propagation system which is exactly built for craft brewers. It's directly matching the brew houses that you've seen before. So the brew house, the Craft Star Neo, as well as the Craft and Compact Stars in the bigger versions. Yeah, it's directly made for that. How that it's scoped, I explain a little bit later. So to make that happen, we designed 3 standard sizes. In hectoliters, mainly 5, 15, and 25 hectoliters, which is working volume. Yeah, compared to the big craft brewers market in the US, it's 4, 10, and 20 barrels. The concept that we've taken here is the basic concept that we are selling to all the industrial brewers. That product is called the Yeast Star product, and that would be a completely automated propagation and assimilation system, which is integrated into a cellar of the biggest breweries. So we took that concept, and there's no compromise on, as you see in the last one, there's no compromise on yeast growth and quality because it's all based on that concept. We just try to, apply the best technologies and optimize the price. So you see there's a flow plate. So all the operations are still completely automatic. The only thing you have to do is you have to do some manual operation during CIP, which means transfer the CIP liquid into the vessel, rerouting it to different routes. The CIP cycle in that route is done automatically, but you have to change the ways for 2 times during CIP. Yeah, what we've done is we equipped it with a 19-inch display. This display acts as an, let's say, customer SOP, so an operation manual for the operator. So as soon as he needs to turn a valve, it would be shown up on the HMI, so he can see which ones are green, should be open, which ones are red, should be closed. So, and that is based on also the flow diagram that you've seen. That would be looking like that on the screen as well, so that there you can identify all the valves and you can have them on the flow plate also with a valve tags, and then see which valves need to be operated. Here, a little bit of a 3D model, so you can have a little bit an idea about the size. So we have a width of 2.40 meters, and the other side it's 2.60 meters. Yeah, I said it's 3 different sizes. So you see what you can see here. You see the tank, yeah, and you see the skid. And it's the same as Oliver mentioned before. So tank and skid are just connected by flanges. So we transport, it's all pre-manufactured, it's pre-tested, yeah. So we disconnect the tank from the skid, and skid and tank are transported separately, but it can be easily put together. And we actually went a little bit further than the brew house, because this one we would say you can actually install on your own. You just put the tank there, you connect the flanges, all the air hoses are marked with numbers, so you can put all this together. Yeah, and all the electrical connections are also marked with numbers, and I have just connectors. Yeah, it is all automated, and so all the automation is on the skid. The only thing we need, and I explain that a little bit later, is a signal from the brew house, and that is to operate our double-seated valves. Let's go back a little bit to this one, yeah, and you can see we have an air inlet, a steam inlet, we have a steam pre-filter, we have a sterile filter to sterilize the air. Yeah, this can be all steamed to sterilize the whole line. Yeah, and we got a few topics that are a little bit different to our competitors. One is we didn't want to compromise on safety, so that's why we are using a double-seated valve on the word line. So in the end, you're coming in with your word line from here, you connect it to that double-seated valve, and you go further with your word line to your fermenters. Yeah, so we need a signal that word is running through that line, so this valve can be operated to fill the propagator backwards with word before you start the propagation. Yeah. The good thing is by using this double-seated valve, there's a complete safety if you CIP this line during operation of the separator. Some other topics that are different are the top plates, because it's a very top arrangement. We have a fully cleanable overpressure valve. So that has a cleaning module and is actually lifted during CIP. So you will never have the problem as you can have with different other competitors, where it's not a top plate, just an arrangement on a pipe, that the seat of the overpressure valve could stick because you had foaming in the last operation, and then it gets not properly cleaned. The seat could be sticking, and then you get overpressure on the tank. The same applies for us to the vacuum valve. So the tank is pressure and vacuum protected. So let's go through a couple of parts that are unique to our system. One is also the aeration. So many of the competitors do the aeration either inside the vessel and applying a homogenization of the vessel by using an agitator. We didn't want to do that because we want as less inserts in the tank to make it very hygienic and easily cleanable. If you're using a stirrer in the tank, you always get a spray shadow during CIP where you can have residual waste and that can't be cleaned. Some other competitors are using something like a word aeration unit in the recirculation line. So we have a recirculation line as well, but we're not using if the customer wants to, we can also put it into the recirculation line. But normally what we want an independent aeration from the recirculation cycle. So these recirculation cycles are mainly made like this, that you recirculating the whole yeast for a certain time and then you stop. Yeah. And if you have the aeration in the recirculation line, the only time you can aerate is also the time when you do the recirculation. So we have an arrangement from the bottom, which is a spray ball with very, very tiny holes connected by a vent flange and connected to a Vesta aeration valve. So we are aerating from the bottom, which actually promotes also during the time when you're not recirculating the mixing of the tank. And as I said, we are independent. What we've done for process safety is, instead of using check valves, we're using a product trap, because we got the experience that check valves tend to fail or tend to stick, because there's word going to the check valve and then the check valve is not operating properly anymore. So we connected a product trap and applied a double safety. So there's a pressure switch on the airline. So and I said the propagation is completely automatic, so it can run alone overnight. So if something happens to your air and the pressure drops, that would be interconnected to that aeration valve, and we would not do the aeration anymore. So you don't lose anything out of your propagator. Second safety is, if there is liquid going backwards through this trap, there's a low level switch. If this low level switch is operated to drain the liquid inside the product trap for more than X times in a certain amount of time, that would interlock the valve as well. So if there's something happened to your airline during night and nobody is in your brewery, you will come back at the next morning, you will still have your whole propagation volume inside the tank, and you can then fix the problem and restart the aeration and restart the propagation. Okay. So on the left side, you see how the product trap looks like with a cleaning device inside, so that it can be cleaned during CIP as well, and the low level switch. And this is the aeration fitting that is below the tank. Actually, this part of pipe is then replaced by the aeration valve that I just mentioned. So homogenization in the tank, what are we doing? So I said we are not using any inserts in the tank, so we're not using any stirrer. So our aeration is done via a recirculation line. As I said before, we have the wort valve here to get wort into the tank, and that works like that. So if there's wort running through the wort line, we can open the valve, we can put in a amount into that flow meter on the HMI saying we want to fill with X hectoliters, then this will open, it will flow through the flow meter, and the arrow indicates it can measure in both directions. So it will flow through the flow meter will calculate how much volume is inside the tank, and then we will fill up the tank. Then that valve will close automatically, and then you're ready to inoculate via a Carlsberg flask or via a dry yeast the tank and start the propagation. So what are we doing to homogenize? During propagation, we do a pulse pause pumping through that line. The pump has a frequency drive so that we can adjust the flow rate. So we adjust the flow rate, as mentioned here, roughly around 1 meter per second during that recirculation line. Yeah, to have the lowest shear force for the yeast. Some people go up to 1.5 as well, or even to 2. The frequency drive also makes it available that we do the internal CIP, as I said. So as I said, you have to only fill the CIP liquid into the tank, and then this pump is actually doing the whole CIP cycles for the different routes that we are having. When the propagation is finished, the pitching into the wort line is the same. If there's wort running through the line, we can open that valve. You can either pitch by empty signal using that level switch, so it will pitch the whole volume into the line, yeah, or you can pitch by volume. So the propagator can be used in a in an assimilator way. So you leave a little bit of volume in and then top it up with wort again and do a second propagation cycle. So then you can put in an amount of liquid that you want to pitch. It will pitch the amount of liquid, then close it, leave a little bit of yeast slurry in the tank, and then you can top it up with wort and restart the propagation. Yes. So one other thing that I need to mention and that you will see later, yeah, is this recirculation line. This is normally designed like that. So we have an angle out of the middle and we have an angle upwards. Yeah. So that ensures that we get a really, really good vortex and mixing inside the tank. And actually that helps foam breaking as well. So in our normal industrial installations, this recirculation line is at 2/3 of filling height at the cylindrical part of the vessel, which always restricts you in flexibility. So what we try to do with the propagator is to build the biggest flexibility into it that you as the craft brewers can, as Oliver said, make the magic happen, can do whatever you want. The same applies to the control system, but I say something to that later. So we've applied CFD methods, which is computerized fluid dynamics, to lower this inlet point to the lowest part of the cylindrical. So, and ensure still a very good mixing and not having any shortcuts going this way. So this actually was successful. So we can lower this part, and that means that we can give you the biggest flexibility in regards to volume. I said the standard volumes are 5, 15, and 25 hectoliters. So the 5 hectoliter version can already be used roughly with 2.5 hectoliters. The 15 hectoliter one can be used with 5 hectoliters. So you have the direct connection between the different volumes. And the 25 can be used with the lowest amount of 15 hectoliters. Yeah. So if you are on the border of some of these volumes, you actually could buy a bigger tank, which is not increasing the price very much, but you get the biggest flexibility. Or if you have different sizes of CCTs and you want to propagate different yeast styles, and need different volumes, you can use it with either more or less volume in regards to your recipes. The whole system is actually based, so what we base all the calculations on is normally the 1 to 10 dilution rate that you have going into a CCT. So 1/10 of the CCT volume should be coming from a propagator to start the fermentation. We spoke to craft brewers in the US And there sometimes we go down to 1 to 5 or something to get higher cell counts at the beginning if you do high degree of plateau fermentations. Good. So as I said, propagation, so recirculation, aeration, and temperature control are completely automatic. What we have here, we have different cooling zones, so 1 to 3 cooling zones depending on vessel size. These cooling zones are, so we know where the cooling zones are and which are the volumes that are compared with that. So this is why these cooling zones are always interlocked with our system, depending on the filling volume. Why do we do that? As I said, we want to give you the biggest flexibility, but we don't want to waste energy. So if you only fill a 15 hectoliter propagator with 5 hectoliters, that will result in that vessel normally has 2 cooling zones, one on the cone and one on the cylindrical. So that will result that the cooling zone on the cylindrical would normally be interlocked and not be used. So you're only using the cooling zone in the cone to do the cooling during the propagation, so that you're not wasting anything. By now talking about automation, I want to mention that we try to build in the biggest flexibility. So all the automation is not recipe controlled, it's freely adjustable. So what you can do is you can experiment with your different yeasts. What are the best growth parameters? So you can adjust temperatures, you can adjust aeration rates, you can adjust the recirculation times, yeah, and that gives you the most freedom. Yeah. One example that I discussed with the brewer was, you're saying, yeah, but we need something fresh on a Monday, and we know that our yeast is only taking 48 hours to grow on a certain aeration, recirculation, and temperature. And then we just agreed that he would start his propagation on a Friday, but instead of letting it run at 18 degrees, he goes down to 14 or 15 degrees. That slows down the growth of the yeast, and so he gets a fresh, viable pitch being available on a Monday morning. So, and this is, as I said, all adjustable, freely adjustable for you guys to experiment, gain knowledge with your different yeast strains, how it behaves the best. Again, to mention, you can use the propagator either as a single propagation stage, use the whole volume, or as I mentioned, sometimes if you got one yeast strain that has the most production in your brewery, you can use it as a repeated batch process. As I said, you leave a little bit of volume in, top it up with wort again, and then restart the propagation. And you can leave that running for, depending on your microbiology, you can leave that running for weeks. Yeah. We have big breweries that keep this cycle running for 2, 3, or 4 weeks before they stop that completely and then clean it. Okay. Some questions that sometimes arise is sterilization is very often a question. The unit is not foreseen to re-sterilize your wort because you come out of the brew house with a hot wort, which should be reasonably fine in regards to microbiology. So we would not recommend to re-sterilize that, because the only thing you're doing is you're losing time, sugar, and trace elements. So the yeast growth actually should be worse in its second sterilized wort. So that's why we not recommend it. If someone insists, we can also build it in, but that obviously results in bigger costs. So there are a couple of options that you've seen already that Marcus mentioned, a CRP makeup skid that can be used and can be connected to the propagator to transfer the yeast liquid, the CRP liquid into the system. As I said, the CRP inside the system is completely automatic. You just need to do the rerouting at a couple of times during CRP. The rest is completely done by the system. Yeah, at the moment, the system is designed for lost CRP. Yeah, there's the opportunity if your cooling is not sufficient in your brewery, that we can apply a designated cooling unit just for the propagator. 2-vessel version, so the picture you've seen, the control cabinet is big enough to hold the automation for a second vessel. Yeah, pitching and fermentation control, always a big topic. Some of them very expensive, but very useful at some times. that you can have a living cell measurement, a turbidity measurement, or a dissolved oxygen measurement to even better control your process. Again, all these methods normally need a bigger lab to do a calibration. Yeah. But it would result in a more consistent production if you just assume you can always ensure not to just inoculate by volume, but inoculate by living cell count per milliliter, so that you always have a consistent starting culture for your fermentations. And obviously you can also get from us a Carlsberg flask where you do your pre-propagation that then can be used to transfer the lab culture into the propagation system. Interesting for you guys, probably a couple of return on investment calculations. So we are working on calculations that incorporate wet yeast, which is very popular in America as well. So instead of buying dry yeast, they buy a wet pitch from some yeast producers. But this is now based on some figures for dry yeast. And just an explanation, you see, we based it on the craft star and the 3 different sizes of compact star brew houses for the calculation. So the smallest amount is 20,000 hectoliters, going up to 200,000 hectoliters a year, based on our brew houses that we are selling. And what you can see here, so the high cost, high limit means that we are taking a very high amount of pitching to 120 grams of dry yeast per hectoliter of wort with a high price. Then we have a high price, low limit, and the other combination, high limit, low price, and low limit, low price. So by calculating this, and this means that you're using your dry yeast only once. That means every time you inoculate a ferment, also you start a fermentation, you're using fresh dry yeast. And there you see this scale here is years, that even with the smallest brew house, your payback for a unit like that would be less than 1.4 years. Yeah. So this is a single use, maybe not that practical. So what we've done to come to probably more realistic model is we are using the dry yeast 5 times. So you're using the yeast 5 times. So 5 times you harvest it from your fermenter and then reusing it. And after that, you would just discard it. Yeah. And again, there you see with the smallest brew house, payback goes quite up if you are at low inoculation grams and low price. But if you go into high price, you see you're still less than 3 years. Yeah. And with the high inoculation and the low price, you're still less than 3 years. And that may be as an calculation, but as I said, we can always do that based on your case and do the calculation individually. Again, now coming to an end, mentioning a couple of benefits that we have and some things that are probably different to our competitors or big competitors that you know. Some of them are mentioned on this page, some are not, but I'm going to mention them. So first of all, as I said, it's pre-engineered modular process kit that is easy to transport, install, and set up. That can also be done without any of our commissioning engineers. We didn't want to compromise on our gas management, put it that way. So that's why we put a gear vari top on top with the overpressure and the vacuum valve that I mentioned before, which is very often a difference to all our competitors. We don't want to compromise on microbiology and functionality, as I mentioned, with sticking valves and not clean seats of vacuum or overpressure valves, because we want to ensure that you can probably use the system in a repeated batch for more than 1 week. Yeah, we are not using hose connections to your wort lines because we want to make sure that there's a very hygiene connection to the wort line. So you route the wort line directly underneath the skid through a double-seated vari vent, which is mix-proof, so you can have no problems by cleaning the wort line during the propagators running. I mentioned the recirculation lines with the frequency-controlled pump that we see as the best functionality that you can have. sterile air supply with the product trap instead of a check valve. So avoid that check valves are sticking because there was word coming into it and then not working anymore. So that protects your air system completely, that you're not getting anything back. So there's a semi-automated control, as I mentioned. You have the biggest variety to change parameters to experiment with your yeast without having to call an automation engineer to program you a new recipe. Yeah, the propagation process, as I said, is completely automized. Yeah, so you don't need anybody to watch it. Yeah. The gentle mixing with our special recirculation line and the optimized height, so give you the biggest flexibility in regards to volume. Yeah, and the CIP process is also inside the skid. You just have to fill the CIP liquid, and the control panel for acts as an SOP for the operator and gives you high process stability. So, and the operator can actually, by doing 80% of his operations that he needs to do on the skid, he can actually watch what he needs to be doing on the screen without moving. Yeah, maybe some other things to mention that are different to our competitors, and therefore I go back to the picture just a quick. So if you look at this picture, yeah, most of our competitors, and you need to be aware of that, are building the tanks without any insulation. So as long as you're not installing your propagator in a cool room, yeah, you will always lose cooling energy, and you will have something like a water dripping in a cave. Yeah, so because the water from the humidity from the air will actually condensate on the cooling coils and then just drip down. So that was my first presentation regarding our propagation system. And I'm happy to answer any questions now, if there are questions.